Have you guys heard about the heavy metal content in fish?
Yeah, it's so terrible.
You know.
How awful.
Yeah, I saw in the news today that it builds up in the fish and makes it into what we eat.
This tastes like metallic.
Goodness, this is terrible. Someone should really do something about it.
Hi, we're Team 6, and based at APCO, we're looking for a way to address heavy metal contamination in water from metals such as mercury, lead, and arsenic that are produced from BC gold and copper mines.
As you can tell, heavy metals play a large role in the environment. They impact the aquatic ecosystem significantly and can impact the reproductive and survival rates. This is a global concern as this causes flesh toxicity in fish, impacting humans with high levels of fish in their diets.
According to the U.S. Environmental Protection Agency, high heavy metal concentrations in humans can cause acute and chronic toxicity, liver, kidney, and intestinal damage, anemia, and cancer.
So we decided to do something about it and stop this problem at one of its starting points: mining. To counteract heavy metal ions leaching into groundwater or accumulating in natural bodies of water, we went to the tailings.
That's the residue from the mining ore.
Right, and it's usually mixed with water in a wet slurry, which is generally placed in the mining pit, which it has previously been excavated.
Here is covered by water and allowed to sit for the remainder of the mine's life.
While it does usually have a protective layer to prevent leaching, it isn't always effective.
So we came up with our own solution.
Here we have our proposed design. It's a filtration system in the tailings pond, and it combines innovative and novel solutions.
We plan to install a physical filter surrounding the tailings pond and a secondary waste channel, which acts as another filter due to the activated alumina. The entire system will be surrounded by a protective layer in order to reduce the amount of heavy metals which leach into the surrounding water.
This first filtering layer here will be made out of polysulfone and membranes with a grafted polymer of sodium styrene sulfate and polysulfone. These are each material intended to target our specific heavy metals ions and should prevent them from passing through.
However, in the off chance that they do, the activated alumina in the surrounding waters channel will be able to filter the water further through absorption.
Below this water channel will be an essentially waterproof layer to prevent any further contamination. This layer is going to be made out of an eco-friendly material with a low permeability rating: clay.
This way, the water that leaves the system should be clean with a low level of heavy metal concentration, and thus can be used for the surrounding environment or throughout the mine.
Through the installation of our design, mines can be confident that the heavy metals produced won't have a significant effect on the environment, and thus won't have a large effect on humans.
To test our design, we start with a proof of concept where we analyze the risk assumption that the activated alumina would be effective.
After we had confirmed our initial assumption and finalized our design, we moved on to prototyping and testing the next batch of assumptions we had made.
This involves talking to a professional engineer and creating a feels-like prototype to make sure our materials are good.
We received the result that there are few changes need to be made to our design in order to make it more feasible.
Most of these are easily implemented, such as adding a space between filters in order to test the water and using a heavier filtration membrane in order to hold up against wear and tear.
However, a large limitation that we have moving forward is that our filters will get plugged or blinded due to the amount of sediment and the lack of access to clean them.
We also tested our material and came to the conclusion that while clay might be waterproof, the variation we used certainly was not, and thus this was not a viable place to cut costs.
As well, in order to ascertain that our design would be overall beneficial, we conducted a cost-benefit analysis.
Our solution can filter out over 99.9% of harmful heavy metals, significantly reducing environmental damage and protecting our aquatic ecosystems.
This isn't just about the environment, it's about value. For every dollar invested in our system, there's a return of $4.30, thanks to reduced contamination, better water quality, and compliance with environmental regulation. Plus, it's designed to operate efficiently with minimum maintenance.
We're using the best materials like activated alumina, which can absorb up to 10 milligrams of lead, arsenic, and mercury per gram. Our system is designed to treat up to 5,000 cubic meters of water, ensuring maximum filtration with minimum resource use. It's engineered to durability and performance.
The technology we're using is proven. Alumina is efficient, eco-friendly, and designed to last. Plus, it minimizes groundwater contamination, protecting ecosystems for years to come.
Moving forward with our designs, there are a few things that we need to take into consideration.
Access to clean filter and replace the alumina absorbate.
How to convince the BC government and the mines that this is beneficial to implement.
At a lower cost to create more incentive to implement our design.
So we're reaching out to you.
And turn this
Into this.